Good morning, everybody. Today I'll be teaching you a flip-flop, a very important circuit which is used in digital electronics. Now, before I get started, let me introduce myself. I am Mahitosh from the Department of Physics, Bankura Christian College, and the topic of discussion in today's class is flip-flop. In digital electronics, there are two types of circuits that we will be discussing. Number one is your combinational, and number two is sequential circuit. Combinational circuit means it is that circuit in which the output depends only on the present value of the input and it has no memory. Whereas the sequential circuit is that circuit in which the output depends on the present value of the input as well as the past value of the input. So it has memory. Since the output of this circuit, sequential circuit, depends on series of input and sequence of input events, that's why it is called sequential circuit. It has a memory. And flip-flop that I am going to discuss in today's class is actually the basic building block of this sequential circuit. So my topic of discussion, which is flip-flop, comes under sequential circuit. So let's get started. What is this circuit? Sequential circuits building block is flip-flop. A flip-flop is basically a multivibrator similar to an oscillator, and hence a heavy positive feedback is incorporated in the circuit. The circuit will not change the state by itself unless and until it is triggered to change so. Now there are two stable states as I told you. Now there are two identical transistors used in this circuit. One is Q1 and the other is Q2. These two transistors are in common emitter mode and they are cross coupled, means the output of transistor Q1 is connected to the input of the second transistor Q2, and similarly the output of the second transistor Q2 is connected to the base of the first transistor Q1. The two collectors through two resistances are coupled and connected to the power supply VCC, and the emitters are grounded. So this is the complete circuit. The output can be taken either from the collector of Q1 or from the collector of Q2. Call them respectively Y and Y bar. These two resistances are RB1, RB2. These are the base resistors. This is RC1, the collector resistor of the first transistor, and RC2 is the collector resistor of the second transistor. So this is all about the circuit diagram of the flip-flop. Now, to understand the operation of this circuit diagram, let us first assume that Y is equal to 0 and Y bar is equal to 1. As I told you that it is a sequential circuit, so the possible states of the output depends on the initial inputs. Let Y be equal to 0 and Y bar be equal to 1. Now, there are two methods of changing the state. When Y is equal to 0, it means that this transistor Q1 is on and Q2 is off. So there is another state because it is a bistable circuit. The second state is Y is equal to 1 and Y bar is equal to 0. This means Q1 is off and Q2 is on. Y is equal to 1, it means that this transistor is in saturated mode, so that Y is equal to 0. Y is equal to 0 means this transistor is in saturated mode, so no output is coming from here. Similarly, Y bar is equal to 1 means this transistor Q2 is cut off, so that the power supply entire voltage is dropped across this output. Now, how to change the state from here to here? There are two methods of changing this state. From this state Q1 on to Q1 on, Q2 off, to Q1 off and Q2 on, there are two methods of changing. The first method is, method 1 is something like this. So suppose we are starting with y is equal to 0 and y bar is equal to 1. This is 0 and this is 1. Means Q1 is on and Q2 is off. Now, how to change the state? Now, first of all, you see when y is equal to 0 and y bar is equal to 1, y bar is equal to 1 means this transistor Q2 is saturated. It means there is y bar is equal to 1 means here the maximum voltage VCC is there. So this maximum voltage VCC when is coming to the base of this transistor, it will supply necessary forward bias for its conduction to this transistor and hence it will be conducting, making y equal to 0. So naturally y is equal to 0 and y bar is equal to 1 will remain forever. Now what to do for changing the state? Now since y bar is equal to 1, if I now connect this to the ground, what will happen? Y bar will now be equal to 0. If y bar becomes 0 after connecting it to the ground, then 0 voltage will be coming to this transistor Q1 and hence this transistor will not get any voltage for its operation. Naturally this transistor will be off. If transistor Q1 is off, then the whole of the supply voltage will be appear at y. So y then will become equal to 1 and obviously y bar will be equal to complement of it, that will be 0. So this is how you can change the state from here to here. Similarly, for changing this state to new state again to this first state, the collector of it is to be grounded and obviously then due to the same reason this changeover will take place. But problem is that this is a cumbersome process. This is not at all the reliable method. That is why this method is never ever adopted in practice. So what to do to change the state? Now the second method, which is I believe the best method of changing the state of this circuit, method 2. In this method, a kind of input voltages are supplied through two more resistances which are known as R and S. This is R through 10 kilo ohm resistance. This base is connected and give name to this input terminal R. And similarly, there is another 10 kilo ohm resistance through which you supply this input S. So these are the two inputs now which will control the mechanism of this circuit. To understand a clear operation of this circuit, suppose suppose we are starting with y is equal to 0 and y bar is equal to 1. Okay. So this is the initial state we are starting with. Y is equal to 0 and y bar is equal to 0. Now let us see with the help of these two inputs R and S how this change can how this state can change to the other state. Now case number 1, there are 4 cases ahead of us. Number 1 is if R is equal to 0 and S is equal to 0. It means both the two inputs R and S are grounded. No voltages are applied. Then what will happen? What will happen is that since this 10 kilo ohm resistance is connected to the ground, therefore this 10 kilo ohm resistance will be coming in parallel between the base and emitter of this transistor. As a result of which, the biasing status will remain unchanged. So, the status of this transistor, y is equal to 0 means what was the status? Y is equal to 0 means Q1 is on and Q2 was off. So this status will not change because a high resistance connected in parallel will in no way affect the biasing condition and hence this will remain same as it was. So output of it will be 0 and y bar will be equal to 1. Similarly, when S is equal to 0 means when it is grounded, then another 10 kilo ohm resistance will be coming in parallel between the base and emitter of the second transistor. Naturally, the non-conducting state of this transistor Q2, will not be hampered at all. So naturally, y bar will be same as it was. That means y bar will be 1. So under the condition of r is equal to 0 and s is equal to 0, there will be no change in the outputs of y and y bar. They will remain as 0 and 1. So the conclusion is that when r is equal to 0 and s is equal to 0, we are getting y is equal to 0 and y bar is equal to 1. That means there is no change in the output states. This is case number 1. Let's now see what happens under case number 2. In case number 2, suppose r is equal to 0 and s is equal to 1. How can you achieve this? R is equal to 0 and s is equal to 1? Simply you connect r to the ground and s to the power supply. After having done, let us see how the change of state takes place. Now see, when S is equal to 1, previously what was there? This transistor was on, this transistor was off. Now when S is equal to 1, S is equal to 1 means you are actually forcing this transistor Q2 to go into saturation. Q2 was off now, so this Q2 will now be forced to go into saturation. Once Q2 becomes saturated, it will conduct and hence the voltage of this, if I call it Vc2, that will be equal to 0. If Vc2 is equal to 0, that means Y bar will become equal to 1. If Vc2 is equal to 0, Y bar will be equal to 0, Y bar will be equal to 0. As now this 0 voltage is coming to the base of this first transistor, naturally this transistor will not get sufficient bias voltage for its conduction, as a result of which this transistor will be off and hence the entire supply voltage will be appeared at Y. That means Y will be equal to 1. Now see, under the situation when R is equal to 0 and S is equal to 1, Y has become equal to 1 and Y bar is equal to 0. So there is a changeover of state from 0, 1 to 1, 0. So this is the situation under case number 2. Let's now see what happens under case number 3. In case number 3, suppose R is equal to 1 and S is equal to 0. So R is equal to 1 means you are actually giving certain voltage for the conduction of this transistor. This transistor Q1 was, what was the state of this transistor? Q1 was on, off, now it has become Q1 is off and Q2 is on, right. So when S is equal to 0 and R is equal to 1, R is equal to 1 means this transistor goes into saturation. When this transistor goes into saturation, the voltage Vc1 becomes equal to 0. That means Y becomes equal to again 0. When Y is equal to 0, Vc1 is equal to 0, this being coupled to the base of the second transistor, this transistor will not get any bias voltage for its conduction. As a result of which this transistor will be cut off. If this is cut off, then you will be getting the entire output voltage coming at this terminal. That means Vcc is coming here, that means Y bar will become equal to 1. This condition under case 2, let me get back to this case 2, when Y becomes equal to 1 under S is equal to 1, this is called setting the flip-flop. So S is equal to 1 means it is going to set the flip-flop. And when S is equal to 0, Y becomes equal to 0 under case number 3, then it is a case of resetting the flip-flop. So the flip-flop gets reset. Now let us see the last option that is left with us, that is your case number 4. When R is equal to 1 and S is equal to 1, means when both the two inputs are connected to the supply voltage. When both the two inputs are connected to the supply voltage, then what will happen? S is equal to 1 will try to make Y is equal to 1. S is equal to 1 will try to set the flip-flop to make Y equal to 1. And at the same time, R is equal to 1 means it will try to make Y is equal to 0. That means the flip-flop at the same time will try to set as well as reset. This is not possible. This is forbidden. This is not allowed. So R is equal to 1 and S is equal to 1 means simultaneously the Y output will try to become 0 as well as 1 or 0 simultaneously. That is not allowed, that is forbidden. So if I want to, you know, summarize all the inputs and outputs through a table known as truth table, I can write it like this. This is your, this is S, this is R, and this is output Y. So when S is equal to 0 and R is equal to 0, there is no change in the state of the output. That means under this condition, there is no state change. When S is equal to 1 and R is equal to 0, S is equal to 1 and R is equal to 0 means Y is equal to 1. It's a case of setting the flip-flop set. When S is equal to 0 and R is equal to 1, then output is 0. It is a case of resetting the flip-flop. And when both the two inputs are 1, then this is not allowed. This is not allowed. This is just not allowed. So this is all about the functioning of RS flip-flop with truth table. So it is, as I told you, that it is a sequential circuit because initially where the inputs, they will determine the conditions of the output. That's why it is sequential circuit. Now there are other flip-flops which come out of this flip-flop, like a slight modification of this flip-flop will make it to become a D flip-flop, clocked RS flip-flop, toggle flip-flop, and to overcome some of the problems comes your JK flip-flop and also ultimately the master slave JK flip-flop. So let me now see what is the block diagram of this flip-flop. Every time, next time onwards, I will be making use of this circuit as block diagram. This is your Y, this is Y bar, these are the two outputs. This is input R and this is input S and this is input R. So this is the block diagram of the flip-flop. Now let us see in the context of this flip-flop, what is clocked RS flip-flop. So let us now understand clocked RS flip-flop. Clocked RS flip-flop. You see, many times what happens, okay, first of all, let me tell you what is the basic purpose of the flip-flop. Flip-flop actually stores bit either 0 or 1. So it is served as a memory. But many times in digital circuits, data is available in the form of stream of bits of which a particular bit needs to be stored. And what to do for this purpose? For this, clocked RS flip-flop is being used. What is a clocked RS flip-flop? The circuit diagram of it is like this. Two AND gates are used which are connected to the two inputs of this flip-flop, and this is your S, this is your R, and a clock is connected to both the two inputs. So of these two AND gates, the two inputs are such that this is S, this is clock, and this is clock, and this is R, and output is obtained as usual. Now what happens, you see here? When the clock goes low, then both the two AND gates are disabled. Obviously, irrespective of the values of S and R, there will be no change, means both the two inputs S1 and R1 will be 0. If S1 and R1 is 0, we know that there will be no change in the status of the output. So Y and Y bar will remain same. But when clock becomes equal to 1, then S and R, depending on these two values, this flip-flop will function the same way as the normal flip-flop functions. So naturally, this clock has got something to do with the delay. What does this clock indicate? Clock indicates that unless and until clock is 1, these inputs will not be coming to the output. So it is a clock which is actually determining the status of the output. So it is called a clocked RS flip-flop. Now, as a modification of this clocked RS flip-flop, we'll be coming to D flip-flop. So, what is D flip-flop? Let me try to understand what is D flip-flop. In D flip-flop, S and R are joined together through a NOT gate. S and R are joined together through a NOT gate. Remaining circuitry is same as before. Now see what is the functioning of this D flip-flop. Why it is called delayed flip-flop? You see. In the last case, we have seen that when both the two inputs are 0, 0, then the output becomes, or when both the two inputs are 1, output is uncertain. It's not allowed. 1, 1 is not allowed. When both S and R are 0, then also the output becomes uncertain. There is no change. Uncertainty means there is no change. Now look what happens. Here, in this circuit, there is only one input called D input, and this D input is directly coming to the AND gate, first AND gate, and this D input becomes, it gets inverted, and that inverted form of this D input is coming to this AND gate. Now, to start with, suppose Y is equal to, now this is your delayed flip-flop, D flip-flop I am talking about. Now, to start with, suppose Y is equal to 0. When Y is equal to 0, and under case number 1, if I supply D is equal to 1, so what will happen? If D is equal to 1, S is equal to 1. If S is equal to 1, then R becomes equal to 0. So this is clock. If the clock is low, then what will happen? And if the clock is high, then what will happen? If clock is low, then this is your 0, this is 0. So both the two outputs of this AND gates will be 0, and 0, 0 means there will be no change. But when the clock is high and D is equal to 1, so clock 1 and D1 means S will be 1 and R will be equal to 0. If S is equal to 1 and R is equal to 0, then the output obviously will be 1. The output will become 1. It means that D is equal to 1, this input gets transferred to the output. The moment the clock comes in, this input D goes to the output. Similarly, under case 2, if D is equal to 1, if D is equal to 0, then S becomes equal to 0 and R becomes equal to 1. So now S is equal to 0, R is equal to 1 means the output Y will become equal to 0. So this D is equal to 0 input gets transferred to the output the moment the clock pulse is switched on. So why it is called delayed flip-flop? It is called delayed flip-flop because unless and until the clock pulse arises, this input will not go to the output. That is why it is called D flip-flop or delayed flip-flop. Now is toggle flip-flop. Another flip-flop that I will discuss right now is T flip-flop or toggle flip-flop. What is this toggle flip-flop? Look, entire circuitry is same like your D flip-flop. Only a change that is there is, suppose Y is equal to 0. Let me make the connection. A little bit change is there. The Y bar output is fed back to the S input. And let us see what happens to this output when I give in one case D is equal to 0 and in another case D is equal to 1. To start with, suppose Y is equal to 0. Okay. And case number 1, when D is equal to 0, suppose D is equal to 1. So initially I have taken y is equal to 0, obviously y bar is equal to 1. If y is equal to 0 and y bar is equal to 1, then with d is equal to 0, what y becomes, let us try to understand. So being coupled this output to the input S, if this is 0, this will be 1, and this 1 will be coming to this input S, so S becomes equal to 1. When S is equal to 1 and when the clock pulse is used, then S is equal to 1 means this will become equal to 1, because as soon as the clock is switched on, this 1 will be transferred to the output. So what is the output? It was 0, now it has become 1. The moment this output y becomes 1, y bar becomes 0. If y bar becomes 0, this 0 will be coming over here, and then this S terminal will become 0, and as soon as the second clock pulse arises, this 0 will be transferred to the output, so it will become 0, and obviously this will become 1. It means the output of this flip-flop is toggling between 0 and 1. That is why this is known as toggle flip-flop. So in toggle flip-flop, this last 1 condition is not there. Here only one input will be there, and after the switch is after the clock is switched on, that one will be there, and it will keep on changing between 0 and 1. So this is your D flip flop. So I think that's all for today's class.